Hi everyone, Renato here speaking. Hope you can hear me right now. And we can probably start. So today I would like to talk to you about, give a first look at Aurora Serverless V2. What is Aurora Serverless V2? Is one of the latest products from AWS. My name is Renato. I work as a cloud architect. I'm principal cloud architect at Funambol. I've been working with AWS technology for about 10 years, so I'm old enough to have seen quite a few new products out there. And I'm AWS data hero, whatever that means. We can now think about, as any cloud architect, any person that is interested in AWS technology, of course, reInvent is one of the major events. Latest reInvent, December 2021, was just a few weeks ago, well, a few months ago now. Hope you can hear me. I hope you can hear me right now. Yep. And that was last December, and everything was online, was just a virtual event. There was nothing that was online. What happened there? First reInvent, first day of the reInvent, Andy Jassy presented his first keynote. And the keynote, one of the major announcements on the keynote of the current CEO of AWS and future CEO of Amazon was Amazon Aurora Serverless V2. The very same day, of course, there was a blog post that announced the availability of the preview, that is MySQL 5.7 compatible edition of Aurora Serverless. And two words really catch my eye that day, that catch my attention, that were not really much the feature, that were more or less the same feature that are currently available for Aurora, but that are now, well, now in the future available for the serverless version. But there were two really key words that I saw in that slide. The very first slide introduced was the V2 and reinvented. What do I mean with V2 and reinvented? Well, first of all, is the very first problem you have there is Amazon, AWS never really used the V2 concept. I mean, they introduce a bunch of products, bunch of new feature every time. They tend to iterate, add feature. They hardly get out with a V2. And so first question I had was, what's wrong with the V1? What's the one with the server, Aurora Serverless has been out for now GA for less than 3 years and reinvented. So I was quite curious of what was happening behind the scene with that. And if you think about AWS approach, it's not Google. I mean, with positive and negative, but Google has even a website dedicated to product killed by Google. So I was quite surprised of this V2 announcement. I mean, if you think how Amazon, AWS still has products that have been there for over 10 years that no one is supposed to use anymore, like S3 reduced redundancy or Amazon SimpleDB, they're still there, they're still fully supported. And there's not a V2 version of it. It's just simply there. So let's go and look under the hook what happened with Aurora Serverless V2 and why they need to have a Aurora Serverless V2 and give it a try on a quick demo. So first of all, just to catch up, to be aligned, what do we mean by a serverless in the case of a database? Well, we are not talking about a function as a service, but we are talking about a database that has to have at least 4 major characteristics. The first one is be somehow highly available. The second one should be that there should be no server maintenance, because of course, if I can access the server and I have to patch my operating system, it's not serverless. Key point, I should be charged for usage. I mean, I shouldn't be charged. I mean, of course, the storage is something else, but for compute capacity, I shouldn't be charged if I don't make requests to my database. And there should be some form of continuous scaling. So let's see what is continuous scaling and what we expect to have. So basically, we want to have an elastic relational database. We want to have an elastic MySQL or Postgres database that performance have few basic things. It's a database cluster that starts up, shuts down automatically if there are no traffic, and almost all scale up and down capacity based on my application needs, what we have live. And why do we want that? We want that because basically, well, at least me, I'm a lazy cloud architect. I want that my application that scales maybe at the application layer automatically using auto-scaling group or container, Kubernetes, whatever I'm using, that the database running behind can somehow scale according to my traffic, and is not just to be sized at peak load for forever. AWS has offered some kind of scaling, auto-scaling capability for some time. I mean, for example, Aurora offers some auto-scaling for Aurora replicas, but still the core database, the master, is still running as a continuous running instance. And well, you can scale yourself an instance, of course. You can do some vertical scaling with some Lambda functions, some logic that according to the CPU or according to the number of connections, you scale your database, or you can size for peak load. But all those things, all that scaling done by yourself will require some significant downtime or significant operation activity. So 3 years ago, less than 3 years ago, Amazon introduced the Serverless what we now call V1. That was an auto-scaling configuration. Main feature was that you don't have to define anymore instance size. You don't say anymore, I want M5 large, M5 2 extra large. I don't want anymore 64 gigabyte of RAM. I'm just simply have a CNAME, an endpoint, and there's some scaling happening behind the scene. Initially, it was compatible just with 5.6, then they introduced compatibility with 5.7. It's been GA since August 2018 on MySQL, 1 year later for Postgres. And the cool feature is, if you think about not reinventing the wheel, not changing your application, you're basically still able to run your application using the same TCP connection. If you have a Java web application, you're using a JDBC driver, you can connect in a very same way. And they introduced as well an API layer if you want to access the database, the same database using API. How was that done? How is still done? Because that's the only GA version at the moment. There's a proxy fleet running there with some warm pool of database capacity, but technically behind there are really instances. There are instances of different sizes. So when you scale your instances, you double your instance size, or you scale down by half your instance size according to the traffic you have. What were the design use cases? Well, development as machine, of course, any application with intermittent load, unpredictable load, and as well some of the basic serverless scenarios. What was one of the cool features, because until what I introduced now was, well, you could do it yourself with some Lambda function on your RDS or Aurora, was the ability to do not drop. By default, Amazon Aurora Serverless doesn't drop a connection. What does it mean, doesn't drop a connection? Well, you might design your application to reconnect. Actually, you should, or whatever you're using a pool or not. But the idea that it's entirely transparent to the user when the database scales is pretty cool. Now, reality is a bit more complex because reality is there's a proxy, there's some instance warm pool behind. So what they tell you is, well, actually, we might not be able to scale your application if you have some long-running query or transaction in progress or temporary table or table locking. So basically, we can scale either if you let us drop connection or if there's a point where we can scale up and down. The data API was quite messy, but they're still there. You can do basically using API, using authentication. You can just basically run queries on your database. So far, so good. Pretty cool. What were the main specifications? Well, now try to figure out what are the main limitations of this approach that require to reinvent, re-engineer the entire Aurora Serverless and get a version to announce as a preview. Well, the scale up was done on two metrics, CPU at 70% or a number of connections at 9% by default. The scaling was reasonably quick compared to do it yourself on RDS on Aurora, but it was still taking up to 1 minute, and then there was a cooling off time to scale down and so on. So you're talking about milliseconds, minutes, you're not talking about milliseconds. Scale down required two characteristics: the CPU below a certain threshold, 30%, connection in that case below 40%, all very cool. But there were no read replica. There was some wake up time up to 30 seconds. What is the wake up time? If you define that you really want a serverless one, that if there's really no traffic, it goes down to 0 and you don't pay compute capacity, there's some wake up time on the first request that can be up to 30 seconds. That means that is that acceptable? Maybe for a test development scenario, yes. In other scenario, maybe not that cool. You can keep a small capacity that is 1. Capacity is 1 to 256, what Amazon call ACU, Amazon Computing Unit, and that's more or less any computing unit is 2 gigabyte and associated resources. So you can get basically an instance going up to almost half a terabyte of vertical scaling, but it's a vertical scaling. There are no read replica. There's never been a read replica on V1. It still takes many seconds to scale. It's available only inside the VPC, so you cannot access from outside. You cannot replicate your data outside. There's no dump to S3, no import from S3. And there's very limited configuration that you can do on that instance. But also one of the features that we haven't mentioned when we were saying how it's designed is everything is happening inside a single zone. So if Amazon loses that zone, they will create a new cluster in the new zone, but that's going to take a few seconds, so you might have a significant downtime. So it's not a multi-AZ deployment. So there are many cases in production where that's entirely put off the users of the serverless V1 version. So here it is, serverless V2. What do they announce? What do they claim that's going to do? It's again an endpoint without an instance size. We'll see in a second. There's some incremental scaling. What does it mean, incremental scaling? Well, before we were talking about scaling up your instance, doubling every time, we see that incremental scaling is something much more interesting, much more useful in production. You're going to pay per use. Unfortunately, you're going to pay more than the V1, about twice, with some caveats. It's multi-AZ by design. It's supposed to start, at least in the preview, is 5.7 compatible. What's going to be when it's GA, we don't know. It's already in preview for MySQL. You can access the preview. It should be in preview in the first half of 2021, according to the press release for Postgres, so pretty soon. And again, you can connect using your TCP connection, so whatever you're doing with your application, you should be able to do it. What are the key features they tell you? Well, more or less, it's a serverless version of the traditional Aurora. So plus the incremental scaling. So they're telling you there's going to be a multi-AZ, it's going to be global databases, it's going to be read replicas, up to 15 read replicas, and they manage them for you according to the traffic. There's going to be backtrack, there's going to be parallel queries, there's going to be performance inside. You might say, wow, amazing. Well, we'll see in a second. The key point as well is the scaling is going to be fast. They're going to tell you that they're going to auto-scale in milliseconds, not anymore many seconds or minutes, but millisecond based on application load. Cool. Very great. So the scaling is now going from, instead of scaling up from 1 to 2 to 4 to 18 to 8 to 16 to 32, 64, and then you're almost done. You're now scaling. You can add even half a unit. So you can go from 1 to 2 to 2.5, 3, we see with a demo in a second. So basically, you can increase or decrease capacity by half capacity unit. Why they use a capacity unit of 2 gigabyte and you scale by half of it, I have no idea, but more or less you're able to add or remove 1 gigabyte of RAM to your database in a matter of milliseconds. So as well, your InnoDB pool buffer size is going to increase in a matter of really milliseconds. How is designed? Well, that's from a presentation at re:Invent. There's some router fleet. And the cool part is that, of course, you can scale up to 256 when it will be available. So half a terabyte for read-write, but you can as well scale in read-only capacity up to 15 read replica, each one of them up to 256 ACU. So you can add quite some load to that database out of the box, and they manage it for you. That's all great. You go, you sign up for the preview, you start to play with it, and well, you start to narrow down what you can test, because of course the preview doesn't include anything. So the preview does include, well, performance side, proxy backtracking, cloning, global database, multi-master, Aurora replicas, Amazon authentication using IAM, and not even the data API for Aurora Serverless V1. So the fact that they mention for Aurora Serverless V1 almost sounds that there's going to be an entirely different API, data API for V2, or there's not going to be a data API. No idea. Furthermore, there's further limitation in terms of what you're going to do in this Aurora Serverless. V2, the preview is only, so you can basically just test the scaling, the incremental scaling. And as well, there's going to be a limitation that is just between 4 and 32 ACU. So you cannot scale down to 0. You cannot really see a database going down to 0 and sleep and wake it up. So you cannot test that part as well. And you cannot go farther than 64 gigabyte of RAM. So, well, in terms of console, nothing really changed. Ugly as the standard one. All very similar. And there's not much you can change. Again, you can change, well, the password and the size at the moment is hard-coded between 4 and 32. You can change the value, but in that range. So far, so good. So I thought, okay, I want to see the difference. I want to see how it really works. There are some nice presentations from AWS that shows you how it's going to happen. And they show you things like, well, that's a graph where they show you running a test scenario with an application performing some orders on a website. And that's line number 1, simulating some orders and a web application with peak, not peak, scaling up, scaling down. And behind number 2 is the line of the database capacity. And you can see that it scales up pretty quickly and intentionally scales down in a much smoother way, because of course you don't want to lose entire capacity in a matter of 1 second, but you might want to wait a bit longer. But well, I'm lazy. Don't trust numbers like that too much. I wanted to just do a very simple test. So what kind of test we can do? Well, I thought I have 2 empty databases. I have the Serverless V1, Serverless V2. Let's create a simple table. Let's say with an ID, some date time, some value that we randomly assign, a primary key, and just throw it 5 million records in the table just to have something that takes a few minutes. Use a store procedure to do that, call it once, sleep a few minutes, and just call it a second time. Again, a very basic test. Of course, it doesn't cover many scenarios, but again, what we have available as a feature is still quite limited. So I was just curious to see how it works. If you run that table, you run it. I would love to run it real time, but I just don't trust live demo. You can see a couple of interesting things. First of all, for Aurora Serverless V1, I started as well at 4 ECU, as we see in the slide in a second, just to make sure that we start at the very same point for both of them. And in the subtraction between start and end time, I removed the 5 minutes of sleeping time, because that doesn't really matter in terms of computing capacity of the database. So if you subtract that, you see that the V1 took about 19 minutes to execute just short of 20 minutes to execute my simple store procedure twice. The Serverless V2 took just over 11 minutes. So almost half. Wow. Well, not so fast. Let's see a few metrics. Serverless V1, what happened when I run at almost 6 p.m. UTC, my system? Basically, the CPU scales up in the V1 almost to over 80%. Then it scales down for a few minutes. It goes down to basically close to 10% again. Second round, more or less similar. And then it goes down. So CPU goes up to over 80%. V2, the peaks are much narrower because, of course, we saw that the execution is going to be significantly faster. And you can see that the CPU, actually, the average CPU is just over 35%. And already you can guess at this point that probably the capacity that was thrown to the task by the serverless version is very different. And that's indeed the case. So very first interesting thing is on the very first run of the V1, you can see that basically between 8 p.m. Central European time and 8:25, so when the task ended at 23, there's no capacity growth. It stays at 4, and by the time it grows at 8, that then will scale down after 8, after that 1 hour range that I'm showing here. Basically, it scales up too late. By the time I'm done, it scales up. So that's already highlight the first problem of the V1 is if you have a task that scales quickly, that by the time you address that one, that is not that cool. What happened with the V2? Well, you see a couple of, and so it was scaling just from 4 to 8, basically, no major change. What happened with the V2? Two interesting things happened. Well, first between 5:59 UTC and 619 UTC, basically the scaling is immediate and is much more granular, and it goes up half a unit whenever, but is narrowed down, and it goes from 4 up to a maximum of 16. So that's a positive because it speeds up the execution of the task. At the same time, when we then are going to compare the cost, we have to keep in mind that our task was much faster on the V2. So we are going to pay less in terms of time, but we're going to pay many more ACU that cost double price by default. So that's already quite an interesting comparison. But the very key point of comparing those two graphs is that there's really, while in the V1 and V2, in terms of CPU are very similar, the way that they scale is entirely different. The V2 really, while the V1 scales too late and doesn't basically follow my simple, quite stupid load, the V2 scales really as expected and in a very granular way. Now, 3 obvious questions. Is this open source? No, there's nothing open source here. It's a fork of this case of the 5.7, and we wish we'll see something of it, but basically the answer is no. Quick answer. Lock-in. Well, is there any vendor lock-in here? We are definitely not in an Oracle scenario or a license scenario, but is not a straightforward answer when you play with managed services on AWS. I will say that the more you go, of course, from running your whole MySQL on EC2 to running RDS to running Aurora Serverless, the less you have control of the system, and the less you have a real ability to get the data out. Yes, you can always dump your database and get the data out, but the complexity increase. And for example, you can always, of course, well, running a MySQL on EC2, you can do whatever you want. Running RDS, you can always, for example, create a read replica, a standard asynchronous replica outside the cluster, outside AWS, and start from there. And that's a very easy way to get out. With Aurora, it gets a bit more complicated because maybe you start to use features like, I don't know, trigger Lambda function that automatically couple you with the cloud provider. And with the serverless one, it's even more because you don't have anymore the ability to create your own replica outside, at least at the moment. Pretty hard to dump to S3 and so on. So the limitation keep increasing. So it's not that real locked in, but it's something to keep in mind. Cost. Let's close with a key point that is cost. It's always hard to compare this solution. I mean, if you compare EC2, Aurora running at 64 gigabyte with running having the capacity of 64 gigabyte on the serverless V2, you're probably paying 2-3 times more with serverless. But of course, the serverless is not designed to run full capacity all the time, because that's really not the desired use case. That's not why you want to use a serverless one. And that's pretty unrealistic to have always 100% capacity. At the same time, I will say that is a bit optimistic, the Amazon announcement that you're going to save 90% of your cost. Even comparing V1 with V2 is pretty hard. So before it's much faster V2, but the capacity goes for the very same task going significantly higher. So at the moment, you say that more or less you pay for the same ECU, but the ECU in the V2 are more expensive. They cost twice the ECU in the V1. Of course, you have it as well, the trade-off that you have a multi-AZ scenario. So pretty hard to say. I close with this summary from Jeremy Daly. It's quite a good summary of the status. Is cost of Aurora Serverless seem very high, but the difference has to do with scale down time and scale up. The policy is very different. So the simple fact that it takes much longer to scale up and down, the V1 might add extra cost. So you have to basically to run and see if it really makes your sense. So to summarize, the key point of this presentation, we are still in very early day. You can access the preview. Only a very limited subset of features is available in the preview, and fair enough. It's it's an iterative process. So at the moment, the thing you can really test are the ability to have an incremental scaling in a millisecond, or anyway, almost unnoticeable time, and that's really cool, promising. There's still not the ability to pause the load, so you're not able to go down to 0. You're not even able to go down to 0.5 or 1 ECU. So before you're still starting with 80 gigabytes, so it's pretty hard to test that part. And of course, most features are not there, but it's an interesting, promising new product. A few resources in this slide. It's going to be available online later. And you can find the slide, of course, on the Percona website, on my own website. You can contact me on LinkedIn or wherever you want. So with that one, thank you, and I'm available for questions. Let's see if I find one. A question, okay. I start from the bottom. Say, suppose I bought capacity, but the charge will be auto-scaled. Any technical downside to Aurora non-serverless? Well, I think it's pretty hard to say right now. I mean, officially, the V2 is supposed to be the same. The goal, at least on the presentation, is on the announcement, is we want to give the same full set feature of Aurora and give you the ability to run it in a serverless mode. The preview, for different reasons, is not there yet. So as for now, the main downsides are really that there are mostly features are not there. Hopefully, that's not going to be the case. In the official documentation, it says failover mechanism takes longer for the Aurora provision cluster. The Aurora Service V1 is currently undefined because it depends on demand and capacity of Renato within the. Can you yeah, on the V1, that was part of the problem. Is there was no real. I mean, the failover to a different zone was undefined because basically it was really moving all your capacity to a different zone. So I was pretty hard to have that time. And that's one of the main reasons, at least, where they claim that they really need to reinvent it and get the V2 out there, because that was unacceptable for any production, for most production deployment. So you needed to have as in Aurora, a significantly lower failover time to address it. I expect from the way they design it, the way they're talking about it, that's gonna be the same as they claim now for Aurora. So it should be the same as current Aurora, not as the serverless V1. Otherwise, they wouldn't make any sense. Again, is a feature that the multi-Z part is not tested, is not part of the preview at the moment. Big question on top. No, I think that's the same. Okay, sorry. Sorry, I missed the question at the beginning because I was scrolling down. So suppose I'm not sure I understand the question. Say, suppose I bought capacity, but the charge will be auto-scaled. If someone can add some information. Yes, the payment will be charged according to, well, according to 2-3 different metrics, but the main one are, of course, your storage. I mean, that even if you have no traffic whatsoever, you're going to pay for the storage you consume. And that's the same logic that you have currently in Aurora. And instead, the compute part, you're going to pay for the usage. That means that for getting 1 second the preview, you're if you have zero, if you're able to go down to 0 ACU, so you have no traffic, and as currently in the V1, you can say I'm going to pause. I decide to flag the option that after a few minutes of inactivity, you're going to pause the database. At that point, you pay nothing. Otherwise, you pay for how much ACU you're going to consume over time. And that's what makes really hard to compare the cost, because if your traffic fluctuates a lot, is usually significantly cheaper than run a instance size for peak time. But if your load is quite constant or significantly is quite predictable, maybe there are other ways to save. That usually is cheaper not to run a serverless version. And the basic price for the way they announced it until now is the basic price for ACU is double the price of the serverless V1. That's related to the multi-AZ. And of course, there's as well the claim that, of course, it's pretty hard to compare the two, because if you, at least in theory, if in the V1 you scale, let's say you have a capacity of 16 and you need to go to 18, in the V1 you are going for 16 to 32 because you are doubling the size, so you are paying for 32 ACU. In V2 you pay more per single ACU, but at least in theory you should be able to go from 16 to 18. Now, that's the theory. When you do a test yourself, as we saw, you see that actually you are not really, you have a much higher number for the V2, but at the same time, the execution time is significantly shorter. So that means that as well, what you're going to pay is smaller. In my case, in my very simple test, you will basically still pay more on the V2 than on the V1. And that's, well, with the caveat that you're using a multi-AZ. Thanks. Okay. If there are no other questions, I thank you. And I stop the sharing. Of course, feel free to contact me here in chat, connect with me, and enjoy the rest of the day. Bye.